Okay, so welcome back. Now today we're going to start a brand new series. And in this series we're going to show you how to develop this really awesome and fairly simple application that you see here. Now what does this application do? Well, as you can imagine, this is a flight tracker, and what it does is you can tell it any location just about anywhere in the world, I believe, and it will give you streaming data defining any detected aircraft in a certain location at a certain range. And in our case, I've got this set up so that it is detecting aircraft here in the United States in California at a location called Palm Springs. And I'm centered here on the Palm Springs Airport in California. And I've told it to every second or every 2 seconds give me information about all of the detected aircraft within, in this case, you see down here on the left, 30 miles radius of this Palm Springs Airport, and give me information on all the detected aircraft. And I take that information, that streaming information, and again, it's coming from a free web server that you can get the data for free every second. And I'm taking that data and I am generating images for each of those aircraft, placing them in this picture box, and I'm showing their relative location and I'm showing their relative heading. I'm rotating these images you see here, these aircraft images, and you can see down here I've got 9 flights detected within 30 miles of the Palm Springs Airport. I'm also calculating the local time at this location. And you can see that we've got a bunch of aircraft, and some aircraft arrive within this 30 miles and then other aircraft are leaving. So every second we have to take that data and we have to refresh this to show all of the aircraft that are in this radius. So we're going to have to remove the old ones and add the new ones and so on. And you can also see over here on the left, I am printing out some information that we're also receiving in that stream, other than just their location and the heading, for 4 random aircraft out of these 11 now. We've got 11 aircraft. I'm printing out a little bit of the tons of data that come for each of these aircraft. And for example, I've got the company name for each of them. We've got a UPS, United Parcel, American Airlines, FedEx, and another American Airlines. It's got the aircraft description, the Airbus A300, Boeing 737, Boeing 767, Airbus A321. And it's also got the distance. We're calculating the distance for each of these from this center location at the Palm Springs Airport. We've got 26 miles, 20 miles, 5 miles, and 15 miles. We've got the ground speed for each of them, 537 miles an hour. And we've got a very important bit of information for each of these, which is the call sign, which is a unique identifier for each of these aircraft. And we're going to use that so that when an aircraft comes in, we're going to assign that call sign to, as you can imagine, like a little picture box with the image of the aircraft. And we're going to assign that picture box to that aircraft, that call sign. And as long as it's showing in the stream, it's going to be assigned that call sign to that picture box, so we can just update it each second and show a different heading in a different location. And we've also got the track or the heading for these aircraft. To the right is 90 degrees, straight up or north is 0 degrees, and straight down or south is 180 degrees. And in this case, straight to the left or west is 270 degrees. So we've got 90 degrees, 82, 96, and 263. And again, this is just 4 random sets of information for now we've got 12 aircraft in this airspace. So you can see they're updating every second or so, and they're putting a new location. And what we're going to do is we're going to show you how we can develop this application. And again, we're going to be doing a lot of things here. So it's a great opportunity to learn a lot of different areas. We're going to be grabbing data from a web server, and we're going to learn how to grab the data, how to parse it, and how to convert the data that we receive to place those on our graphical images. keep in mind that each of these aircraft has, for example, a location, latitude and longitude, but that doesn't help us put it in our bitmap here in the picture box. We're going to need pixel locations. So we're going to have to do a lot of conversion between latitudes and longitudes and relative pixel locations in this picture box. And we're going to have to figure out how we can rotate these images to match the track or the heading of each aircraft. And we're going to, as I said, have to take the call sign and make sure we assign it to a picture box so that they're always tied to a certain picture box. And then when the aircraft goes out of the airspace that we're monitoring, we're going to have to reassign that picture box. So behind the scenes, we're going to have to do quite a few things to get this to work. And ultimately, we can have this basic application to which we can add a lot of functionality later on. But for right now, we're going to look at the basic functionality, how we can do this, and how we can get these updated images every second or two. So now let's start with the number one most important aspect of anything associated with engineering or software development, and that is the design phase. And unfortunately, a lot of people like to jump past this part. You know, the newbies and the novices and the hobbyists just want to write code. But to do so is a huge mistake, and especially in something like this where it can get kind of complicated. You have to think about how you're going to do this, and you have to plan it out. So what we're going to do is we're going to go through the design phase first and figure out how we can do this. And then once we've got all that, we're going to figure out some what's called pseudocode. We're going to write it out in English. And then once we've got the pseudocode, writing the actual code, which is really the easiest part, is pretty simple. We just take the pseudocode and, put if statements and so on. So let's start looking at the design phase of this. So as you can imagine, there's going to be about 3 major functions in this application. First of all, we're going to be getting info on all the flights that are detected every second or two. Then we're going to have to do a lot of data processing because, we might have 20 or 30 or 40 flights. Each one has got a lot of information associated. We only grabbed 5 or 6 bits of information, but there's tons of information available for each flight. So we're going to do a lot of data processing, and that's going to take some time. So we're going to have to make sure we don't take too much time, or else our display is going to be very slow. And then once we've got all that figured out, we're going to have to figure out how we're going to display the data in our picture box. Now, as we said, all of this is going to happen every second or two in a time step. So we can imagine we're going to have a system timer set for 1 or 2 seconds. And it's going to go through this, process all the data, display it, and then start all over again. Now, some things to keep in mind. This data on the flights is going to be from the internet, from a server using an API. And it's going to be free, but we're going to have to send it some requests and we're going to receive some data. And since it's coming from the internet, we're going to have to be very careful. We're going to need to do a lot of error checking to make sure that we have good data and that we understand what the data is, what the format is it a string, is it a double, or is it a float, and so on. And we're going to have to do a lot of checking to make sure we've got what we think we've got. Also, something to keep in mind, this data is going to come to us every second or two, which means all of the data we get is the latest data. There is going to be no history basically in that data. So if we want history, like what's the path of the flight, what path was it taking, what is the historical data, there's none of that. So if we want history, we're going to have to think about how we're going to take that data, the real-time data, and add some history to it. So keep that in mind. Now, once we've got that data in whatever format, we're going to have to process it. Now, this data we're going to get is going to be in what's called JSON format. And it's going to be one big string, one very long string of data that represents all of the flights and all of the data associated with the flights. So we're going to have to do a lot of parsing of that received JSON string. Again, it's a very, very long string, and we're going to have to parse that It's in JSON format, so that could be a lot of work. And again, lots of data that can represent many flights. So we're going to have to, parse that out and assign each flight to a picture box or an image or so on. So there's going to be a lot of that parsing and assigning and keeping track. So there's going to be a lot of work there. And if you just jump in and start writing code, you're going to be very disappointed because you're going to get going down a rabbit hole and you're going to forget about some of this stuff and it's going to be a mess. So now that we've got all of that assigned to picture boxes or whatever, we're going to have to display the data. And that raises a big issue. How are we going to display the data? And we're going to see there's multiple ways that we can approach this, but we're going to have to be thinking about how we're going to do that. And we're also going to be thinking about what is the data structures for all of this, right? We're going to have real-world aircraft. We're going to have graphics information representing those aircraft. What are the object-oriented classes representing the aircraft? How are we going to represent the graphics associated with the aircraft and so on? So there's a lot of things we need to consider. Now, we mentioned that the data returned from the server every second or two is a JSON string. And here is one very, very simple example of a string that we might receive for just one aircraft. So it's a big, long string with a lot of stuff. And you can imagine you have to parse that. You have to use regular expressions or whatever. That can be a real nightmare. But basically, it's got all of this data. And what it's got, you can imagine, if this is going to represent one or more aircraft, there might be an array of data where you can have multiple members of the array. And also there's going to be like some header data that has some general information. So we're going to have to figure out how to parse this and how to get useful information from it. Now, thankfully, there is a fairly simple library available in Windows Forms, C# Visual Studio that will allow us to take this string returned from the server and parse it and automatically convert it into a class that we develop. So it's going to take that string with, 10 or 20 flights, so it's going to be 10 or 20 times this long. And thankfully, you can use this JSON converter. However, we're going to have to generate a class or set of classes that we can take that data and send it into those classes. And those classes can only contain whatever data we want. A lot of this data we don't care about. In our case, we're going to need location and heading and also a unique identifier, the call sign we talked about. So we might want to grab just maybe 5 or 6 bits of information from all this. So we're going to have to make a class that has properties of those 5 or 6 bits of information. So we're going to have to think about that, but thankfully there is a way to do that. Also, we said that there is going to be an array of aircraft represented by this. And you can see here in red, I've italicsed the type of data we'll get for the aircraft. You can see there is an AC here, which represents aircraft, and it's a colon, and it starts a bracket for an array. And you see go down all the way down here is the closing bracket for the array, and that represents one flight, one aircraft. And it's got a lot of data associated with it. And as you can imagine, for 10 aircraft, there's going to be 10 times that. All right, so there's all of this data we're going to have to parse and convert to a class. And you can see if you look in here, there might be some things that look familiar. DESC is Airbus A320. So that's description of the aircraft. Alt baro is barometric altitude, 37,000 feet. Track, 113.55, that's probably the heading. So we can start to see that there is some useful data here that we can extract. Again, we don't need 90% of this stuff, but we can make a class that has description, barometric altitude, and track, and maybe some other information that we can actually use for our application. So what are we going to need? Well, we're going to have this image of an aircraft. It's going to have these locations, latitude and longitude locations. You can see here, latitude, longitude, which is a decimal value in this case. So it's going to give us these latitude and longitudes. We're going to have to do something with that and convert it to what we have in our picture box, which is an image with pixel values. So we're going to have to figure out how to convert that and also to get a heading and rotate this image. So the important things we're going to need is a unique flight registration or call sign, which is identifier for a particular aircraft. That's going to be a string. We're going to need the latitude called the LAT and longitude or the LON, which are doubles, and also a heading called the track so that we can place and rotate the image and also have a unique identifier so we can assign it to a particular picture box or however we're going to display it. So we're going to need an R value, which is the call sign, a track value, which is the heading, and then a lat and lon, latitude and longitude, for the location. Again, we're going to have to convert those to something useful. So once we've got that, we're going to have to do some processing and figuring out how to implement it. So we're going to have a registration number, latitude, longitude, and track, and then the latitude and longitudes are going to define points. We're going to have to convert those to pixel values, and then the track or the heading, we're going to have to figure out how am I going to rotate we're going to have basically an image we're going to have to rotate. So the question is, each time step, am I going to rotate that by a value relative to 0? Or is it going to be an incremental where I have to keep the previous value, and if it changes, I'm going to rotate a little bit? So it's those kinds of things you need to think about because they're going to be very important. But these are the really big important things, the registration, latitude, longitude, and heading that we're going to need. So we're going to get latitude and longitude, real world values for the actual aircraft. However, our image is based on pixels. So we've got an X pixel value for a location and a Y pixel value. So somehow we're going to have to convert a latitude and longitude value for each flight at each time step into a X and Y pixel value. And this, as you can imagine, can be kind of complicated because our application knows nothing about latitude and longitudes. So we're going to have to say, what are the relative latitude and longitude values and how do we convert those to pixels? So that can get kind of complicated. But first we're going to have to know what are latitude and longitude. For example, in our image, the latitude is a measure from north to south in degrees, but we're going to use decimal values. And for example, up here in our map in Palm Springs in California in the US, the top part of this image is going to represent a latitude of about 34.3 degrees. Down at the bottom of the image, that's about 33.4 degrees. So we're going to somehow have to say, well, 34.3 degrees is the 0 Y value in pixels for this image, and 33.4 is the maximum Y value in pixels. So we're going to have to figure that out. We've also got the longitude. In our case, in Palm Springs, the image, the left-hand side of the image happens to be a longitude of minus 117.5 degrees. And the far right side is minus 115.8 degrees. So first of all, we're going to have to figure that out. For whatever image we use, we're going to say, what is the latitude values of the top and bottom so we can convert those to pixels? And what is the longitude values of the left and right so we can convert those to pixels? So we need an algorithm to map latitude and longitude to XY pixel coordinates. To determine the heading or the rotation of the image each time step, we need the previous rotation to determine the incremental amount, or can we always rotate from 0 degrees? So that's something you've got to think about. If we have an image that is rotated like this, we develop an image in GIMP or something and it's rotated like this at maybe 45 degrees, if that doesn't match the actual rotation of the aircraft, we're going to have to figure out how should we rotate this image. So we're going to have to do some thinking about that. And again, we're going to have multiple images. We can assign each image to a picture box. Are we going to rotate the picture box, or are we going to rotate the image inside the picture box? Those are things we're going to have to think about. And again, we're going to have to do that for every aircraft. And we're going to have to handle multiple flights and picture boxes and images simultaneously. So you can see this can get kind of complicated and a lot of work. And we're also going to have to do this fairly quickly so we don't slow down our display. So now that we have an idea about what the challenges are, in the next video what we're going to do is we're going to start at the very beginning, and we're going to see how we can grab data, the JSON string data, from an internet server, and how we can bring that data in and we can parse it into a class or a set of classes that we can use in our application. So I encourage you to hang around and watch the next set of videos so you can see how to do this. So that's about it for this one. If you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.